Okay, this is the 12 p.m. Zoom meeting, Math 1111, sections 2.6 and 2.7. We'll start in by working some problems here. Page 252, this is section 2.7. Start in working some problems. We'll start with problem 7, this off page 252. Problem 7, f of x equals x, g of x, 2x, and they want you to find a whole bunch of things here. They don't really separate it off in parts. F plus g, f minus g, fg, and f divided by g, and domains. Remember, on domains, we have a participant. Miss Rainwater, how you doing?
I'm doing pretty good.
Let me turn up my volume. I think my volume is low.
I might have one. Your volume is good. I think mine, I need to grab my microphone.
Okay, I'm up on my volume now, and
Let's see.
there.
Is this
No problems. Automatic answer. For domain is domain negative infinity to infinity. All right, I was just charging into problem 7. Do you have some problems you'd like to see? Because it is a bit of a project, but it's a pretty easy one. They want you to write down these 4 things and the domains when you do these 4 operations. Did you have anything you wanted to see?
I was hoping we could go over section 2.7 because it's
Okay.
a little confusing to me.
All right, well, that's where I'm at. I'm on page 252. What could we show you from section 2.7?
I guess we could just work a few of the problems.
Is 7 good enough? It's the very first one.
I'm not sure which one.
You want to see a more complicated one?
That's perfect. I can see this one first.
Okay, did you say you'll see this one first?
Yes.
Okay.
That one works.
All right, what we'll do is we'll write down each of these 4 things and the domain with it. Notice that individually, your domain up here is minus infinity to infinity. Neither one of these things have problems. They don't have a square root, they don't have a fraction. Domain here, negative infinity to infinity. So all they're really asking you to do is on this first one is just simply add them. F plus g would just take x, add 2x, and you would get 3x. And that doesn't create any problems, so it's domain negative infinity to infinity. That's really all they're asking you to do. Now, further down the page, the functions get more complicated. But this first one isn't too bad. F minus g would take x and subtract 2x. That would give you negative x. Again, that doesn't create problems, so its domain is negative infinity to infinity. Let's see if anybody else showed up. Okay. Are we going too fast?
We're good. We're good at the moment, I think.
Okay. Well, fg just says to multiply. In other words, this is the add function. This is the subtract function. This is the multiply function, and this, is, of course, is the divide function. All right, So if I go FG, then I'm taking the formula for F and simply multiplying by the formula for G. And that just gives me 2x squared, which again has no problems.
Okay. All right.
So on the fourth one, when I take F divide by G, I would take F then and divide by G. I would go ahead and cancel my x's, and that would leave 1/2. And once again, there's no problem with the domain.
That makes sense. So it's like last unit where you're replacing the F and the G with what they equal. So
With their formulas, yes. And then these first four things are simply adding and subtracting, multiplying and dividing. The add, subtract, and multiply doesn't usually create problems. The divide can create problems because you got to look where your G could be 0.
okay.
Do you want to see an example of that? Say number 9 or?
Yes, that would be good.
Okay. And then after that, we can get into some that have some more domain problems.
Okay.
Number 9, your f of x, this is still off page 252. Your f of x is x squared add x, and your g of x is x squared. They don't, like say, separate these in parts. I guess I'll just write them down in the order they give them. So f plus g would simply take x squared add x for f, add x squared for g. Then you're looking to combine like terms, and so that would give you 2x squared add x. And you can see no domain problems, domain negative infinity to infinity. Questions about that?
No, I think that makes sense.
Okay.
I like
Okay. F minus g would simply take x squared add x and subtract x squared. You got to really watch. These have been pretty simple with only one piece on the g. You really got to watch. You got multiple pieces. This minus sign distributes, but with one piece, you don't have to worry about it. That's going to cancel the x squared. It's leaving you the x. And again, no domain problem, minus infinity to infinity.
All right.
So, yeah. I'm sorry, go ahead. Did you have something?
I was gonna say, if are there any instances where the exponent changes, or is that gonna stay the same throughout this?
Yeah, no, it's going to change on this next one. Yeah.
Oh.
FG would take x squared add x, so we'll put in parentheses, and multiply by x squared. Now, yeah, you could leave this alone. If there was something else here, I probably would. I'm going to go ahead and distribute it. If you distribute it, you're taking x squared times x squared. Remember, the exponents add, so that's x to the 4th.
Yeah.
Then there's a 1 there, understood. So when they add here, the 2 there plus 1 there, that gives you x cubed.
Yeah, because the exponents, instead of multiplying, they add, right?
They add. When you multiply terms, your exponents add.
Mm-hmm.
Just quick reminder. So if I had x squared times x cubed, that's x to the 5th.
Okay.
If I take x squared and just cube it, that's x to the 6th.
Okay.
And if I take x squared and add x cubed, I hope you know this is unlike. Can't be done.
Yeah, that's just
It's tricky. It's a little tricky.
Yeah.
All right, so now notice, let's see, domain here, negative infinity to infinity. There's still no domain problems. But now when I go to divide them, I'm taking the x squared, add x on top, dividing by x squared.
Oh, and
I'm not going to simplify this out. I theoretically could, but I'm not. But you see you've got a domain problem.
mm-hmm. Yeah, you can't have an x. You can have variable with an exponent.
Yeah, and you got to figure out the number that's the problem. Can you tell you're setting x squared equals 0? Do a square root, and your x is 0.
Can't have that. Can't have that.
Can't use 0. So I'll just graph that out. Put an open circle at 0. Numbers either side, no problem. So the domain, if I have f over g, domain, negative infinity, 0, 0 to infinity. So I'm using parentheses here. I can't use 0.
The brackets would be if it was if it was on that number, right?
Yeah, if I could use 0, I'd have brackets.
Yeah.
But then actually, if you could use 0, it'd be back to this. So yeah.
Yeah, it would. Okay, that makes sense.
Okay.
I feel like I remember. I almost remember this, but I don't know if quite all the way. So this is really good. It's really helpful.
You want to see one further down in the section with domain problems?
Yes, I would love to see that.
That would be something like 15.
15? Okay, 15.
Got 2 fraction problems.
Oh. I see it. It's the f of x equals 2 over x and the
2
g
over
of
x
equals 4.
And your g of x, 4 over x plus 4. I'm not going to make you simplify things when you write it out. So when I do f plus g, I'm just going to go 2 over x and add 4 over x plus 4. Now, that may not be the answer in the book. The book may get a common denominator and do that. That's fine. But I'm not going to make you do that. This is fine.
Mm-hmm. Okay.
Now, here's where things turn into projects. Is
Oh,
trying to puzzle out your domains. You just basically have 2 fraction problems. Your x can't be 0. And can you tell it can't be negative 4?
yeah, because then it would make 0 in the denominator.
So graphing that out, you're going to have negative 4 first, open circle. 0 second, open circle. But anything other than that is perfectly legal.
All right.
Can you write out your intervals? Negative infinity to negative 4. Negative 4 to 0. 0 to infinity.
Oh, that makes sense. Yeah.
Questions about that?
I think I got that. I'm just gonna have to work hard on trying to remember how to write them because I know how to do the infinities on each side, but the middle one is one I'm gonna have to remember.
Remember, yeah, you don't have to test anything. With fractions, you don't have to test anything. Just identify your numbers on the bottom that make it 0. -4 here, 0 there, and you can use anything in between them.
All right.
Now, once we've done this, this is really where all the work is, because the rest of them are going to have really similar domain. In fact, basically about the same thing. If I do f minus g, you just take the 2 over x and subtract the 4 over x plus 4. And you see, you still can't use 0 or -4. It's got an identical domain. -infinity, -4. -4, 0. 0, infinity. You don't have to redo all your work. And I think you'll find the same thing when you multiply them. FG, that'll take 2 over x and times 4 over x plus 4. And you can multiply your top and get 8 over x and x plus 4. But you still can't use 0 and you can't use -4. So domain doesn't change. Questions about that?
So problems with fractions like this, is that kind of how it's going to be? Its domain is going to be very similar, if not the same.
A lot of these things, the domain is similar. Now, when we divide them, that could change. The first 3, anyway, a lot of the domain's very similar. When you divide them, weird things happen. So let's see what happens on this one. All right, so I'm going to take 2 over x, and I'm going to divide by 4 over x plus 4. All right, now that's going to take 2 over x, and you see you multiply by x plus 4 over 4. You remember when you divide fractions, you flip the bottom one or second one?
Mm-hmm. Yeah.
Which puts the x plus 4 in the top. So that would make, go ahead.
Sorry.
Let me check the answer in the back on this one. They might do it off of this form, and still you can't use -4 and 0. Let's double check and see what they're doing. They might get tricky with it. 2, 7, it was number 15.
It still says we can't use -4 and -0.
And 0, and you still can't use -4 and 0?
Yeah, you still can't use -4 and 0.
Okay, so they're doing it off this form, and so they're keeping the domain the same then. Okay. -4, -4, 0, and 0, oops, 0, infinity. Okay.
All right. I don't remember the other problems in this section. I know we have 27 to 31.
Right.
57.
Now, that gets into the 5th operation. It's called composition. I didn't get to mention this at 12 o'clock Zoom meeting on Monday. Composition. All right. They use a little circle. So you'll see this used a lot. I call it FOG for short. All right, it's not multiply. Not multiply. They want multiply, that's FG. They'll use nothing between them. This is multiply. What they mean is, it's read F composed with G. And they really mean f and put parentheses g of x. So what you do is you plug the inner or second. Written this way, it's the second one. This is second. Into the first. In other words, I plug G into F. Now, in 27, you're given f of x, 2x minus 3, g of x, 4 minus x squared. They give you an A and a B. Part A, find f of g of 0. Okay, I don't really have to mess with the entire x's, although I could do it that way. With this, I basically do it in 2 steps. Step 1, find the g of 0. Well, that means this is your x. That means plug x is 0 into here for the g. So g is 0 is 4 minus 0 squared by itself, and that's 4. So when I have f of g of 0, I now know that 4 goes right there. So in effect, I'm finding f of 4. It goes for this entire thing. So I would put 4 in for that g is 0. And so step 2, if you want to call it, is find f of 4. That means plug 4 in for x into the f. That'll come up 2 times 4, subtract 3. That's 8 minus 3, which is 5. Did that go too fast?
No, that was perfect. That was perfect. So
Yeah, with no. Go ahead.
You're finding G first.
The inner one.
Yeah, and then you're putting that inside of F, and then you're solving for F.
Right.
All
right. So they'll, this little section does it with numbers. We can do maybe, I don't know if you want to see another one. And then the last section, 47 to 57, is back to more projects. It does it with pure X's, and they want domains. Want to see another one of these?
Can we see some of those? From 47 to 57?
Sure.
I feel like those might end up being the ones that I spend the most time on.
Right. This is similar to the very first section. They want 4 things. By the time you do all 4 things and domains, you have done a project on each one of these. Where did I go? Oh, all the way to 57. Okay, so is there any, you want to see an easy one like 47? Or a little tougher?
Can we do,
which one?
We can do an easy, then a hard one if that's okay.
Yeah, easy one then a hard one?
Yeah.
Right, try 47 then.
47.
On page 253. All right, your f of x, 2x plus 3, g of x, 4x minus 1. All right, again, they don't separate them out, A, B, C, or D, so I'll just write them down in order. F, little circle G. I'll do all the steps. This means f of g of x In plain English, it means plug G into F. So that's F of 4x minus 1. So I've replaced G with its 4x minus 1. So this means place this entire thing in for x in the F. That'll give me twice 4x minus 1, close parentheses, and add 3. Questions about that?
No, because then it'll be 8x minus 2
Plus 3. Yep, that's 8x minus 2 plus 3. Yeah, and that'll become 8x plus 1.
Woo, yay.
Easy domain, minus infinity to infinity. It's got no problems. We're really not going to have any problems with domains until we hit F divided by G. Not F divided by G. May not have any problems with domains on this. There's no divide. It's plugging one into the other individually. They got no problems. So we may not have any domain problems on this one. This one may be so easy. You want to see the other 3?
Yes, yes I do.
All right, they switch it. G little circle F. This means plug F into G. Do you want me to keep writing out all the steps, or do you want me to show you how to shorten it?
I guess writing out the steps is good.
Okay. This is going to take G of F of X. That'll be G of the 2x plus 3. That's short. See it? Yeah. Replace F with the 2x plus 3. Now I plug the 2x plus 3 into G, where the x is. So that'll make 4 times 2x plus 3, and subtract 1.
Mm-hmm.
8x plus 12, subtract 1. 8x add 11. Domain, again, minus infinity, infinity. That too fast?
That was great. That was great.
Okay, the last two plug F into themselves, F into F, and G into G. So if I do F little circle F, I'm taking F of X. F of the 2x plus 3. So I'm plugging the 2x plus 3 into itself, in effect, giving me twice 2x plus 3, add 3. Questions about that?
No, not in that one. That makes sense on that one.
All right. 4x add 6, add 3. 4x add 9. Again, no domain problems. I don't think we're going to have any domain problems on this.
That's a relief for those.
All right, the last one is, I call it GOG, G-O-G, G circle G. Are you ready to plug G into G?
Yeah.
Okay. Are we going too fast?
No, we're going at the perfect speed. This is great.
G circle G. G of X. Let's take the first one is the outer one, and you plug the second one into it. So G by itself is 4x minus 1. Putting G there. So now I'm plugging, in effect, G into itself. So 4x minus 1 goes there. 4 comes 4x minus 1 minus 1. 4x minus 1 minus 1. (16x minus 4 minus 1). 16x minus x minus 5. No domain problems. Minus infinity to infinity. All right, it's just long. Yeah, that one was super simple. It was just long.
Mm-hmm.
So by the time you get to 51, you got a fraction problem. 55, a fraction problem, and 57, you got fraction problems. Anyone in particular you'd like to see?
Can I see 51?
51. Page 253. Your f of x, 1 over x, g of x, 2x plus 4. All right, all four of them. F, circle G. F of g of x, that'll be f of your 2x plus 4. Just writing out all the steps. Can you tell that's going to be, see, I'm putting this in where the x is in f. 1 over 2x plus 4.
Mm-hmm.
Too fast?
Yeah, it's good.
Okay, so you see I got a fraction problem.
Yeah, fraction.
I got to take 2x plus 4 equals 0. You might be able to do it in your head and figure out it's negative 2.
Yeah.
But if you want to solve it, 2x will be negative 4, and your x would be negative 2. You can see it, it's 2 times negative 2 to negative 4, add 4, you'd get 0. So remember, you can't use this. So I can't use negative 2, open circle. Anything either side's perfectly fine. Domain, negative infinity, negative 2, negative 2, infinity. Questions about that?
Nope. Yeah, because
Yes?
simplify the 2x plus 4 as well, and then get the x plus 2 and use that and get the negative 2 from that as well, which is good.
Yeah. I'm setting this to 0.
Mm-hmm.
Track the 4 over gives you negative 4, and then divide by the 2, you get negative 2.
Mm-hmm. Yeah, that makes sense.
All right. Are we ready to switch it to G, circle F?
Yes, we are.
Okay. We're going to plug F into G. Are you ready to shorten it up, or you want to still see all the steps?
Let's shorten it up. Let's see how it goes.
See how it goes. All right, so this is the phrase I use. You plug your second into your first. So that means I'm going to plug F into G. So if I put F where the X is in G, can you tell I'm going to get twice 1 over X, add 4?
Yes.
I'm putting the formula for F wherever there's an X in G
Mm-hmm.
is the,
Oh, okay. Yeah, I see it now.
is the secret. Now, if you want me to show you the steps, I'll be happy to.
No, that's okay. That one was good. That's good.
Now, can you see you got a fraction problem, but doggone, it's a different number than up here. Your problem number on this one is
It's 0.
0. So this is not as easy as the first ones where if you did the first one, the rest of them were the same. They're making us switch the numbers. So I've got an open circle at 0, shaded. So domain on this, negative infinity to 0, 0 to infinity.
Okay.
Questions about that?
So it doesn't matter if the 2 is multiplying into the fraction, it would still be x does not equal 0.
Yeah, the 2 just winds up on top. I could have written a 2 over x, add 4. Even if there's an x on top, you ignore it. You ignore anything on top. That doesn't matter. It's perfectly legal.
Okay.
What is illegal is having a 0 on the bottom.
Mm-hmm. Okay.
Are we ready to plug F into F?
Yes, we are.
So that would be F, circle F. You want to see the steps, or do you?
We can go straight through this one.
All right. So you're thinking plug F into F. Lost what the F is. So F takes 1 over, and now I got to plug this whole F where that X is. That'll be 1 over X. See, that's my F, and I've plugged it in where the X is in F.
Mm-hmm.
And this is what always confuses me, because it's supposed to flip around and give me X, but they may still call 0 a domain problem here. Let's see if they do. 0 may still be a domain issue, because if I flip it around and get X, there's no domain problem. 2, 7, what are they saying?
Oh yeah, they're still saying it's a domain issue.
They're still saying 0 is a domain problem?
Yeah.
Okay.
That's a little weird.
So yeah. So you're really looking at the domain of the inner function. So X still can't be 0. Your domain is minus infinity to 0 and 0 to infinity. So it's identical to this one still. You see where we're getting the 1 over X?
Yeah.
Okay.
So you're writing it out with because you're just replacing the x and the 1 over x with another 1 over x. So
Right.
it looks like bigger.
You can see how the very first one shortens up. You're plugging G into F. Well, there's G, and you're putting it into F where that X is, and that's what we wound up with. 1 over the 2x plus 4. Are you ready for the last one? Cramped on room, maybe. Go ahead. Go ahead.
Oh no, I was just saying I was ready.
Okay. G circle G, and just to remind, G of X was 2x plus 4.
Yes.
So you're plugging G into G. So here's G, and I'm plugging it into G where that X is. And you see you get 2 times your G is 2x plus 4 plus 4. So So you're plugging G back into G, where that X is. That makes sense, or do you want to see the steps?
That makes sense. It would come out to be 4x plus 12, right?
Sounds right. 4x, and you got a plus 8 plus 4. Yes, plus 12. No
Okay.
domain problems. Minus infinity to infinity.
Oh, that was a good one.
Yeah.
That was a good one.
All right, we're at 40 minutes. Do you want to see any more of these, or do you want to see anything out of 2.6?
Let me look back at 2.6, see if there's anything.
That
I
was
don't
where we
remember.
were. 2.6 was page 242. We were shifting graphs
That's the
up,
one
down,
with
left, and right. Transformations.
We can try one for. I'm sorry, it's just taking me a minute.
Sure, go ahead.
to Find one.
Did you give me a number?
Can we try 71 from
Sure.
that section?
Okay, and that's a bit of a project because there are.
I'll make one.
Yeah, that's fine. We'd have time to do it, but there's 6 parts to it. That's what makes it a project. Okay. Let me copy the graph real quick so we can explain. Some of the parts are pretty simple. This is 2.671. Basically, it's upside down kind of angle. From the origin, 2 in, you're up 4. And over 4, you're back to the x-axis. Okay. This is your given f of x. So A says f of x minus 2. They want you to graph. All right. Did we get across what each of these, this is why they go through these little exercises trying to get you to recognize what this is doing. You remember if this was up, down, left, or right?
That was right.
Right 2, right?
Right 2.
Means right 2. So you do your best attempt. I would just move each of these points right 2 and then just connect the dots. So your origin point's going to go over to 2. Your peak is going to go over to 4 and up 4. And your point at 4 here is going to go over to 6. Questions about that?
No, not on that one. So if it's a negative, it shifts over to the right, and if it's a positive, it shifts to the left.
If they're inside.
Yes.
But notice at B, it's outside. Minus 2. Outside.
Yeah.
So that going to shift it. Do you remember up, down, left, or right?
Negative on the outside is down, right?
Down 2, exactly. So again, we're working off this original. So the origin is going to go down to negative 2. Your point at 4 will go down to 2. 2 over. Down to 2. And the point here will go down to negative 2. Oops. There. Questions about that?
Not in that one.
Okay. How about C? Twice f of x. The way I think about it, I would think of this f of x as your y coordinates, and you're just multiplying your y coordinates by 2. By 2. If you want me to really quickly redraw it, it's easiest to me to just go through the numbers. Does this, 4, this went up 4, this went up to 4, and you're through the origin here. So I write down the coordinates at each of these strategic points. You got 0, 0, you're at 4, 0, and you're at 2 and 4. And literally, I'm going to write down the new set of coordinates with the y coordinate multiplied by 2. So I'll go ahead and show it. So it's 0, comma, and 0 times 2, but that doesn't change. That's still 0, 0.
Mm-hmm.
This one is, I'll go this way so I can save room for graph. 4 and 0 times 2, and that is still 4 and 0. Those two don't change. But up here, 2 and then 4 times 2, multiplying that y coordinate of 4 by 2 until I go to 2 and 8. So I think I got room to barely put it on here. 0, 0 doesn't change. 1, 2, 3, 4 doesn't change. See if I can squeeze 8 tick marks on. 7, 8, over 2 and up 8. It's like you got stretched upward by 2. They call this vertical stretch.
Mm-hmm.
Stretch vertically by a factor of 2. With multiplies like this or even divides, I write the coordinates. You see, you really don't have to write the coordinates when you're going up, down, left, or right. Most people can figure out what points are, 2 to the right. You see that? Don't really have to have the coordinates for that. But I find it helpful, for me anyway, if I know I'm going to multiply stuff, to go ahead and write the coordinates. It's like you pin the bottom of this and stretch the top up by 2, by factor 2. Questions about this?
No, not on that one.
Okay. There's 3 more parts. You want to see them?
Yes, I do want to see them.
Okay. So D, graph negative f of x and add 3. Okay, this gets tricky. I'll redraw it. This is at 4, you're up 4, and you're over 2 with this. Okay, you've got 2 things going on here. You're in effect multiplying your y coordinate by -1 and adding 3, which means you're moving up 3. All right. The tricky thing about this is these things have to be done in a specific order, pretty much by the order of operations. You remember your basic order of operations? You do exponents, then you multiply and divide, and then you add and subtract.
Yep.
On arithmetic.
Yep. And
the same idea. You got to do this multiply first, and then move your that graph up 3 in that order to get the correct graph. Now, if you can do all of that in your head once, I will applaud you and bow down. I'm not capable of it. So I like to separate it out and do just this first, get my graph, and then move that graph up 3. So step 1, I'm just going to graph a straight negative f of x. Now that means I'm multiplying, I'm going to rewrite my y coordinates, 0, 0, 4, 0, and 2, 4. And I'm going to multiply them by the y by negative 1. I'll rewrite them here. 0, 0, I'm multiplying the y by negative 1. So 0, 0 doesn't change. 2, 4 goes to 2, negative 4. And 4, 0 doesn't change. Multiplying those 0 y's by negative 1 doesn't change them. But your 4 here times negative 1 becomes negative 4. So if I graph this, 0, 0 doesn't change. Over 2, I'm down 4. My 4, 0 doesn't change. You see I reflected it around the x-axis?
Yeah.
It reflects around the x-axis. Now to get my answer, step 2, move up 3. So that will take this origin point up 1, 2, 3. This point's at negative 4. Up 3 would put it at negative 1. 2 over. At negative 1. And then 2 over from that. That goes up 3. That should match the answer in the back of the book. You just cannot do these things in random order. If you get out of order, they're not correct.
Yeah.
In effect, you're doing. Go ahead.
It would make it more confusing if you got out of order because they're just.
Yeah, and also wrong. Yeah, you want to do your multiply first before you add or subtract.
Mm-hmm.
Just like your regular order of operations. You ready for the last 2?
Yeah, I'm ready for the last 2.
F of negative x. I don't know if you were there at Monday's Zoom meeting, but the negative inside meant reflect around y-axis. I can also show, if you can't remember that, you do the opposite of what's shown. So really you can get this by dividing. It's showing multiplying the x by negative 1. You can really divide your x coordinate by negative 1. I'll show you from the original graph. Over 4, up 4, and we're 2 over. Here's 0, 0, 4, 0, and 2 and 4. If you divide your x coordinate by negative 1, negative 1, this will stay 0, 0. This will go to negative 4, 0. And And this will go to -2 and 4. Divide by -1 just switches sign. It won't change 0. So my answer zero, 0. I'm going to -2 and 4. And I'm going to -4 and 0. Can you see you've reflected it around the y-axis? Reflect around the y-axis. Questions about that?
Nope. Yeah.
Ready for F?
Yes, I am.
Going to be similar to D. You're going to divide the y-coordinate by 2 first and then move it right. So 71 part F, graph, 1/2 f of x minus 1. Remember, this is the y-coordinate. So you're dividing the y-coordinate by 2, multiplying by 1/2 divides by 2. Then that's step 1. Step 2, shift right 1. So I'll show these as separate graphs. So step 1, divide y-coordinate by 2. Want to see the original? So over 2 and up 4. Here was 4 and 0. 0, 0. 2 and 4. So divide the y-coordinate by 2. Doesn't change the base points. Divide that by 2. Can you see you go to 2 and 2? Can you tell that's going to shrink it by a factor of 2? 0, 0. 4, 0. You shrunk it by a factor of 2. By itself. This too fast?
No, this is good. I'm getting it all written.
Are you ready to shift this graph right 1?
Yes.
Okay. So the origin point moves over 1. My point at 2 and 4 moves over to 3 and up 4. And 4 and 0 there would move to 4, 5, and 0. I am so sorry. I don't know if it's the last problem, but you see what I drew the original, not the shrunk. My fault.
Uh-oh.
My fault. The top should stay at 2.
It's fine. It's been a long session.
Been a long session, yes. So over 1. All right, 1, 2. All right, over 3, 2, and over 5 and 0. Now we got it correct. Yeah, I drew the original shifted right instead of this one. Okay, finally. All right, that was do all 6 parts. That's a bit of a project.
Yeah. But that was really helpful.
Okay. Oh, we're right at about an hour. Have we filled up your heads enough today?
I think so.
Okay.
I really appreciate you staying and helping me, especially with the long ones.
Absolutely. No problem at all then. So are we ready to call it into it?
Yeah, I think I'm ready to call it.
Okay, very good. I will be getting quiz, quiz 5 out by tomorrow
All right.
over these.
Sounds good.
Okay, thank you very much, and we'll see you next week.
See you then.